Hey guys, last video in our series today, and question number 17. I am given some data. The x-axis is actually, it's telling me the x is the dollars earned above $50,000. Okay, so that's my x, and that's my y, which is the dollars paid. So x is dollars earned above 50,000. What does that mean? That for the first value, the x really is 0. And for the second value, the x is 1,000, because it's the dollars earned above 50. And x here is 2,000, 3,000, 4,000. So again, I don't have the luxury of defining x because it's already defined for me. X be the dollars earned above 50,000. So simply, in order to find x, I get all of these numbers and subtract 50,000. That's how I get my x. So the y is the tax paid. So y is the tax paid. So in this case, it's 1800, 1860, 1920, 1980, 2040. And I'm asked to basically find the relation between y and x. And the first question that I should ask myself, of course, I define my units. X is dollars earned and y is dollars in tax. And the first question is this a linear or exponential? And the answer is, how can I tell? I should look for every delta in x and see if the delta in y is basically, see my delta in. So for delta in x, which in this case 1000, what's my delta in y? So the first delta in y is 60. That's 1800. 60 minus 1800. What about the difference between these two? 1920 minus 1860. That's also 60. Awesome. What about this? Same thing. 1980 minus 1920. That's 60. Again, I should check all of them. If one of them is wrong, if one of them is varying more than 60, then it's not a linear function anymore. 2040 minus 1980, that's also 60. So yes, it is a linear function, and I need to find basically y is equal to mx plus b. So the b is my initial value, which is this guy here. So I know that the b is 1800. Still I have to find mx, or basically m. M is the slope, and the slope is equal to change in y divided by change in x. So the change in y between, I can pick any two numbers. Guess what? I already evaluated it. It was 60. That's 60 divided by change in x, which is 1000. So that's my slope. That's equal to 0.06. And my equation is y is equal to m. I already have m now. So it's equal to 0.06 x plus 1800. How can I make sure that? So for these type of questions, please double check your answer. How can you confirm your answer? Very easy. Substitute x. So if x is equal to 0, y will be equal to 1800, and that's correct. That's basically it. Let me check with another value. If x is equal to 1000, y will be equal to 1000, 0.06 multiplied by 1000 plus 1800. That's equal to 60 plus 1800, that's 1860. And this is the value here. So my answer is correct. That was a neat problem. Okay, moving on. We have 2 more left. I can get to sleep. Okay, population of a city is 20,100. That's the initial population in 2015. So that's initial population. According to their development plan, the city should grow 5% per year. Grows 5%, meaning that the R is 5%, which is 5 over 100, which is 0.05. So the base, again, I do this automatically. 1 plus R, it's a growth, so it's a growth, so it's 1 plus R, 1.05. Okay, according to their plan, the city grows 5% per year for the next decade. Decade means what? 10 years. Oh, okay, but maybe this is not an important information. At that rate, how many people will the city add in the 6th year? So first, let me find the relation. N is equal to N initial multiplied by base raised to the power t. And t is equal to 6 in this case, because so N is equal to 20,100 multiplied by 1.05 raised to the power 6. So it's always better to do the power first. So 1.06 raised to the power 6. Is that it? So 1.06. Oops, 1.05. I messed up. Okay. 1.05 raised to the power 6. That's 5.79. And now multiply it. So I evaluated this. 5.79. Now multiplied by 20,100. 20,100. The answer is 116,415. 116,415. This is the population. Okay, let me confirm that I got it right. 116,415. Of course, the 0.5, that doesn't make any sense, so you can round it up or down because there's no 0.5 people. Okay, last question. Finally, an aftershock of magnitude 7 earthquake. So I have an earthquake EQ that has magnitude is equal to 7. So earthquake, magnitude 7. So, and there's an aftershock. So the aftershock is like, this is a secondary earthquake, right? So I have EQ1 has magnitude 7, and then the aftershock of the earthquake, which had magnitude 7, has only 15% of the intensity of the original earthquake. So I have earthquake 1, or you can call it the original, and you have earthquake 2, which is the aftermath or aftershock. Now each earthquake has its own magnitude and has its own intensity and has its own relative intensity. Okay, so let me clean this a little bit. So the first one has magnitude 1 and has intensity 1. This one has magnitude 2 and has intensity 2. So the first one has a magnitude of 7. Now I don't have the magnitude of the second one. Actually, this is the question. What does the aftershock, which is the second earthquake, measure on the Richter scale, meaning the magnitude? Because again, the Richter scale gives you the magnitude. So I need to get this. So I have 7, but I know that the intensities of 1 and 2 are related. So what's the relation? The relation is given intensity of EQ2, earthquake 2. The intensity of the original, the aftershock has only 15% of the intensity of the original quake. This means that the intensity of EQ2 is only 15%, so that's 15 over 100 multiplied by the intensity of EQ1. Interesting. So I have the intensity. So I need to find, first of all, what this is. Intensity of EQ1 from the magnitude. So I have this magnitude. From it, calculate intensity 1. Use it here. And then calculate from this relation intensity 2, and then go back to magnitude 2. Wow, it's confusing, right? So let me erase. Whoops, am I going to erase? Actually, I'm gonna solve it here. I think I should be good. I have enough space. So intensity 1 is equal, so ten raised to the power magnitude, and that's the relation from page 182. So that's 10 to the power 7. Okay. So the intensity 2 is equal, intensity 1 is 10 to the power 7. Now, relative intensity 2 is equal to 15% multiplied by relative intensity 1. So that's 15 divided by 100 multiplied by 10 to the 7, and that's equal, actually it's gonna be 15 times 10 to the 5. So now I have the relative intensity 2. Now I can calculate, magnitude 2 from the formula. Magnitude 2 is equal to log of relative intensity 2. So that's log of 15 multiplied by 10 to the 5. That's so 15 times 10 to the 5, which is basically 2, 3, 4, 5. And then log of this value, 6.17. Okay, so what does the aftershock measure on the Richter scale? The value is 6.17. So the initial one was 7, the magnitude on the Richter scale. We calculated the intensity, 10 to the 7. And then we said that the intensity of the second one is 15% the intensity of the first one. So this made me calculate the intensity of the second to be 15 times 10 to the 5. See, this is 15% of the initial intensity. And then magnitude 2 is, I use the relation from basically page 180. So let me write it down for you. So this is page 180. Okay, so this will be the conclusion of our practice exam. I hope that you guys benefited from it. Please let me know, give me feedback if the video was clear or not. If you need more details, I can maybe work on this better for better videos. You guys take care and good luck in your exam. Bye-bye.